So today we are going to, let's get back into spring, there we go. We are going to continue our discussion of the periodic table and talk about three broad categories of elements and how you can figure out what they are on the periodic table just by looking at that document. A couple other things, business that I don't have on the calendar, I will send out a reminder tonight to have you unenroll yourself, remove yourself from the fall classroom, and tomorrow morning my plan is to archive all the fall classrooms. And so you will get your materials back, your papers back, your work is still in your drive, but I won't have it anymore. So yeah, I will give you a warning tonight, and then tomorrow archive it, and that way it'll get out of your hair. What else I want to tell you on this? So in your classwork stream from yesterday, this is the note sheet that I gave to everybody, and we're going to focus on this bottom half of that note sheet, talking about metals, non-metals, and metalloids. So if you want this up, great. You probably should just have a piece of paper out and take notes as we go along. And yeah, I think that's all I need to say right now. So welcome back. Let's find our PowerPoint and get this show on the road so you can get going and do the assignment. The assignment won't be due until Monday. I think you'll have plenty of time to do it before once we're done with the lecture today. So that should be good. All right, what are the three classes of elements? Well, the three classes of elements are metals, non-metals. See if I can get my pen here. That's good. Metals, of course. I love technology. Oh, and now the cat's here too. Metals. I'm going to keep my good attitude because I can. There we go. Metals, non-metals, and metalloids. And as you go from left to right, they become less metallic. So the metals are on the left, the non-metals are on the right. And those characteristics, again, remember I told you yesterday, as you go across a period, big changes in elements and their characteristics. I'm going to have to get my squirt bottle and squirt my cat. All right, we'll see if that keeps him quiet. It's a kind way to do it without screaming or throwing things. So you'll look on this periodic table. This is on your note sheet as well. The blue region is the region for the metals, and about 80% of all the elements. It includes even the synthetic elements. They're very large. The 80% of the elements on our periodic table are metals. This little weird jig-jag of purple on here, those are the metalloids. They're the confused group. They're the transition group. And then the green are the non-metals. And you'll notice that hydrogen's over here on the metal side. Always the non-metal over there. Well, some periodic tables actually have a little gap because the alkali metals and hydrogen kind of behave a lot alike, but they are not the same. Okay, so most or very many of the compounds that hydrogen makes, remember it has one proton and one electron. Many of the compounds that hydrogen's in, hydrogen atom loses its electron, and that's what metals do. I'm going to talk about that lots more. So all of the alkali metals end with S1, you might remember, and so that is the one electron that is lost. When they do that, they end up with the noble gas configuration S2p6. I'm going to get rid of that one more electron. So at any rate, that's not making sense yet. It will eventually, I promise. Hydrogen does also occasionally gain an electron, so it ends up with 2. It can do that, and that's not that common, but that would give it the electron configuration of helium. So it's a mixed up element. It's the simplest element. It's going to lose, it's going to gain. It mostly loses. So this is the colored version of the periodic table that you've seen previously, I believe. Notice that this stair step, I inserted this over the green region. These green elements, those are the metalloids. They're in between metals and nonmetals, and they have characteristics of both broad groups. But yeah, we'll talk about a very important one in a minute. So this is my favorite kind of periodic table, a chocolate one. Wouldn't that be lovely? Makes me hungry. Good thing I ate my oatmeal this morning. Make a T-chart like this on your note sheet, or, you know, if you don't want to, that's fine, but make a list of the things that I'm going to give you going forward, okay? And you're going to see really quickly that metals and nonmetals are basically opposites. Whatever a metal does, a nonmetal does the opposite. Okay? So metals, again, 80% of them, of the elements are metals. They have something called luster. They shine, they shimmer, right? If you've seen polished metal, gold, silver, even stainless steel, that shininess is something called luster. Other non-metals, some have luster as well, but there's a very high amount of it, and they also call it metallic luster. And they're what we call ductile. They can be pushed and formed into wires. And then they're also, you probably heard this one before, malleable. You can hammer them and they don't break. You can pound them into pots and pans, tools, jewelry, all sorts of things. All of us have probably experienced the fact that they conduct heat. If you leave your spoon in your soup pot on the stove and it's a metal spoon, if you go to grab it, you'll notice that it's hot, just like the soup. They also, of course, you know, conduct electric current. Okay. That has to do with their electrons. We'll be talking lots more about that. Also, most of them are silver colored. Not every single one, but almost every single one, all but 3. Okay, everybody knows the color of gold. It's gold. And the color of copper is copper colored. And then cesium, most people have never seen cesium. It has kind of a rosy gold color to it. Also, all of the metals are solids. The one exception is mercury, and it is a liquid. There's one non-metal that is also a liquid, interestingly. This is a big key point. They react with water to make a basic, which is also called an alkaline solution. pHs of 8 to 14 indicates that characteristics. So when I put hydrogen in water, kind of silly, it's hydrogen, it's water, it doesn't really do anything. But if we put sodium or potassium in water, they make hydroxides, which are alkaline, hence the name for the group 1 elements of alkali metals. Second group is alkaline earth metals, and we'll get into all the names next week. And then finally, the biggie. This is huge. You've got to know this. Metals lose electrons. That is a big deal. They form something called cation. Ions are atoms that have gained or lost electrons. For metals, they always lose. And I have this little silly way, losers, right? You know, that symbol. Losers on the left. Metals are on the left of the periodic table. We'll be talking about cations a lot soon. So again, losers on the left are the metals. And of course the elements down here. But remember, they would fit in here anyway. So they're still on the left. What are they left of? They are left of the nonmetals and the metalloids. This looks like it's a little offset. The metalloids are underneath there, so I will have to fix that. At any rate, they are things that you would think of as metals, like iron and nickel and copper and zinc and silver and gold. Maybe you realize that chrome is also, and titanium and vanadium. Not many people know what this one is. The old name is wolfram. It's tungsten. That's what's in traditional light bulbs. At any rate, these are the things that you think of as metals, the transition metals. But what most people don't realize is all these things over here are also shiny silver solids in the pure state. You just don't see them by themselves in nature. They're always combined. Another element to make a compound. Oh, and then of course the aluminum too is a metal. Duh. Okay. All right. So iron, this is, you look at that and go, oh, that's steel. Well, guess what? Steel is simply a mixture of iron and carbon at the bare minimum. There's high carbon steel, low carbon steel, or what's the term? Mild steel is for low carbon steel. So those of you that are into welding and stuff may be familiar with that. A wrought iron is just iron and carbon. If you want stainless steel, you got to throw in some nickel, throw in some chromium, maybe some vanadium, maybe some other stuff. But stainless steel is what's in the arch. Probably some of you have stainless steel fixtures in your house as well. But steel, when you hear the word steel, you need to think iron. Okay? Obviously, everybody has some aluminum in their house. Aluminum is used for lots of things. It's low density, so it makes for lightweight patio furniture and things like that. It can be, it's very malleable, right? We can roll it out into a sheet, which everybody has used aluminum for, I'm sure. And then copper, of course, is used for electrical wiring. Copper is also used on the bottom of some pots and pans because it's a good conductor of heat. So it evenly distributes the heat on the bottom of a cooking vessel. But it also is really good at conducting electric current without overheating. When copper's price started going up in the 80s to really crazy amounts, construction, it actually started in the 70s. Construction was allowed with aluminum wiring. I actually lived in a duplex in Lompoc years ago with aluminum wiring. The problem is aluminum is more resistive. It has more resistivity, and so the aluminum will actually heat up more. And if there's any break in the insulation on the wire, it causes fire. So the California Building Code doesn't allow aluminum wiring anymore in houses. You have to use copper. And of course, we know all the meth heads like to come and rip out the copper wiring from places, sell it for scrap metal. But at any rate, I digress. So you also probably know in your toaster, the wires in your toaster or toaster oven get red hot. That's because they have a high resistivity. Just like the tungsten wire in a light bulb glows. It goes from red to white really fast, but that's because of its high resistance. And that's why you can bake cakes in your Easy Bake Oven. Anybody have an Easy Bake Oven? Back in the day. All right, so that is those are some common metals that you're familiar with in everyday life. Non-metals are in lots. They're the predominant elements in biological compounds. So organic compounds are compounds that have lots of carbon. Primary organic chemistry is carbon chemistry, the whole class of elements, but physiological, biological chemistry involves lots of non-metals. You, being a living being, have lots of compounds with non-metals. You have some metals in you too, but again, where metals are mostly solids, most of the non-metals are gases. Notable exceptions, carbon, phosphorus, and iodine. And again, there is one liquid non-metal. And when we say this, it's always at room temperature, and that's been established to be 20 degrees Celsius. Many of the non-metals have unique colors. Now, all the metals except gold and copper are silver, but the nonmetals have different colors. So there's red and black phosphorus. Of course, carbon is black if you think about a charcoal briquette kind of carbon, but it's also gray if you think of graphite, and then it can be colorless like a diamond. Sulfur is yellow, iodine, like I showed you yesterday, is kind of that gray silvery color, but its gas is purple. It's nuts. Okay, and bromine's brown. They also have unique odors. You probably have smelled the rotten egg smell of hydrogen sulfide before, that sulfur smell. And of course, you've probably smelled chlorine at the swimming pool. They have unique odors to them, distinctive, identifying odors. Another characteristic is that they shatter when they're struck. So I can take a piece of metal, if I have a big enough sledgehammer, I can smash it into flatness. However, when I take a piece of carbon, again, think of a charcoal briquette or some sulfur or any other solid, if I hit it with a hammer, it's going to shatter into little bitty bits. It's not malleable. They're not malleable. They're not ductile. Also, again, they, instead of an alkaline, they make acidic solutions. Their pHs are less than 7. And again, the biggest, most important thing for our purposes, talking about chemical reactions, they will gain electrons. They form anions. Okay? An is a prefix that means like negative, anti. Okay? So if you get more electrons, you become more negative. Anions are negative, cations are positive. I think it would have been better if they called it wrong. So again, here's our nonmetals. Again, hydrogen is a nonmetal. Nonmetals are on the right, and they include the noble gases. All right, metalloids, the confused group. They are in between. Depending on the size of the atom, they're somewhere in between here. If they're small metalloids, they're more non-metal-like. If they're large metalloids, they have more metallic. We'll talk about why that is next week. All right, so if you change the temperature, interestingly enough, their behavior also changes, their chemical reactivity, which is common, but also their physical properties, of course. They live on this stair step. So aluminum's a metal, and it actually lives right under boron. But if you make a stair down around these elements, all the elements that touch that staircase on aluminum, it's always a knot in every chemistry rule, they are what we call the metalloids, and they have in-between properties. So remember we talked about germanium yesterday. Germanium's a metalloid, and actually germanium was used as the first in the first computers. We ended up switching to silicon, however. And of course, you know, there's a place called the Silicon Valley over in San Jose area. And you know that's where the semiconductor industry is. Hopefully, anyway, now. Okay. The interesting thing about metalloids is they are semiconductors. They conduct a little bit, just enough. Not like copper, not like a metal, but they do conduct a little bit. Even the graphite in your pencil, the carbon is not a metalloid, it's a non-metal, but even the graphite in your pencil is a semiconductor a little bit. But silicon's below carbon. These are silicon wafers. And so what they do is they purify, so silicon dioxide is the most common compound in the Earth's crust. That is what's in sand, most sands, unless they're seashell based, but most sand at the beach is silicon dioxide. And of course, you probably know that quartz, which we have tons of around here, is silicon dioxide. They purify and get pure silicon. It's this beautiful, it's a really, really pretty in its pure form. I have a chunk of it at school, and I'll try to remember to have that out when we come back to campus. But they purify it and then make it into like, they're called pigs, like they used to do for iron, but they are rounds, and then they slice them super thin, And they make these little wafers that they then stamp out the little computer chips and then put all the, somehow magically put the gold on there to make the circuitry for your computer to work with. So that's a quick introduction to the three main categories of elements. And I want to open it up for any questions, comments, anybody? Okay. Well, if you're still awake, I'm going to show you the activity I want you to do. And
excuse me?
yes.
May I ask a question?
Yes.
I was looking through the assignment that you had posted on the class earlier today, but I noticed when you drag the elements into the table, they go behind it. They don't show up.
You don't drag the elements into the table. I'm going to show you how to do it right now.
Okay. Sorry, I just got a bit confused because they just disappeared and I didn't know where they went.
So let me show you how it works. All right. So on your classroom feed, you should have this assignment. And I just wanted to point out that this little button will get you a link to a periodic table. And the periodic table looks like this. However, that's not where you want to stay. So, oh, did I lose it? There it is. So on the next slide is what I would like you to do. And so these boxes are element boxes. And it says fill the element box with the correct color. So when you click on, so let me just go off this, there we go. So, oh, let's show it. So until you click on something, you don't see the little fill bucket. But once you click on it, the fill bucket shows up right here. And silicon, like we just said, we were just talking about it, is a metalloid. So when you click on the fill bucket and click yellow, it will fill in as yellow. Okay, and that's what you're going to do with the other elements here. So lithium, look on the periodic table, lithium's over here on the left, it's metal. So you're going to fill lithium with red. So once you've highlighted the box, then you fill it with red. Right? List at least 3 characteristics for each of the main broad categories of elements. You don't have to fill all the information in, but you can if you want to, of course. And we will go over this again on Monday to make sure that you got it right. The last slide of this is just a quick drag the circle and tell me how you feel about the lesson review. And this is due before we meet again on Monday. Love you, bye.